friends, in this video we are going to be going over hypotonic versus hypertonic versus isotonic solutions and what happens to our cells when they are in these solutions. First off, let's get some vocabulary straight. So a solute is what dissolves in a solvent. Like, for example, it could be salt. A solvent is what dissolves the substances, which is the solute in this case, and that could be something like water. A solution is the solute and the solvent together. So when you put salt into water, you see it dissolves. Salt is a solute, water is a solvent, salt water is the solution. Let's say we have 3 cups of our solutions here. So let's say the solvent is water and then our solute is salt. So in the hypotonic, there's going to be very few of our solute. In our hypertonic, there's going to be a lot of our solute. And then isotonic, we'll just put a few of our solute in there. Now let's drop a cell into each of them. Each of these cells are also filled with a solution. As you can see here over with the hypotonic, there is more solutes inside of the cell than there is outside of the cell in the hypotonic solution. So our water is going to want to move to wherever the most solutes is. So water is going to be moving into this cell. This causes the cell to expand because there's so much fluid in there. This can actually cause the cell to burst. That's called cytolysis. If you put a cell into a hypertonic solution, there's more solutes outside of the cell than inside of the cell. So the water's going to want to move out of the cell. This causes the cell to shrink and shrivel up. And it can actually die from this. This is called plasmolysis. Now if you drop a cell into an isotonic solution, this means the number of solutes inside the cell is the same of the number of solutes outside of the cell. So water doesn't rush in or rush out of the cell, it just keeps homeostasis. So this makes for a happy cell. Now this doesn't mean water does not move in and out of the cell, it just means that there isn't a big rush. So there might be a little bit moving out and a little bit moving in, but it stays at homeostasis. That is it for these basic concepts that can be applied to many different things, including IV fluids within the vascular system. If you have any questions, please leave them down below and I will get back to you. And if you haven't watched my diffusion versus osmosis video, I highly suggest go watching that. I will link it down in the description. Alright, thank you for watching. I'll see you guys in the next one.